Thank you, sir. And it's a great honor for me to receive it from Joshi, sir, because the first award I ever won in my life was named after him in KOS, and that was on confocal microscopy at that point of time. I don't remember the year of my presentation, but that was a prestigious one, and even now it's probably the most prestigious one in the state which you can win. Thank you, sir, and thanks Rohit and Mr. Prasad for this. I have a small presentation. We call it as an accidental scientist. The reason is everything happens in life for a reason. There's no accidents, they say, but still sometimes some accidents really happens for good. These are my financial interests. I work with different companies, government organizations. I'm sure it's not going to have an effect on what presentation I'm going to give. Everything in our society has happened with an accident. Whether you look at Coke, potato chips, everything. Even computers, the way Steve Jobs built it all had to start with a trigger or an accident. But all of them, at the end of my talk, I'll give you all of them, even though they look accidental, in clinical definition, had a trigger. And I'll tell you what that trigger is. The trigger is, I just returned from Greece a few days back, and there was a very beautiful thing about Plato. I mean, Greece is the cradle of what philosophy and democracy. One of the question everything was the philosophy of Socrates. And he said that if you don't question, you will never get answers, and you're never going to be a scientist. Whether you're a clinician, a scientist, or just working in your clinic, it's all about one thing: we question. And if you have an ability to question, everything may look like accidental, but you'll still find answers. I think Sir Joshi sir will probably remember these days as his days of being a clinician. We have lost this. Somebody sitting and trying to find a desperately, like you can see in these paintings, which is one of the most famous paintings concerning a medical field or a doctor in the world. One of the costliest painting also, revolving around a doctor. The doctor is as concerned as a father or a crying mother. If you see here, that concern is something which we lack today. And that concern, I think, is what we need to bring back into medicine. And that's all about finding the answer, because we have everything today is looking differently. And what if is always a question. For example, the protagonist of my presentation today is this ophthalmologist, a very well trained cornea surgeon. She comes from not from south, somewhere north. She has been suffering for the last 15 years, trained in best of universities abroad. She just cannot cure her own dry eye. And this is a list of things, combination which she thinks, and she desperately needed an answer. If you can't treat yourself, a doctor not treating thyself, is probably the most difficult thing in life, because you get more mentally, you get completely devastated. Because if I can't treat my own self, how will I start treating my patients? And that is something which I'll bring the story again, is because we are always looking at old ways to treat new things. That is gone. This is a slide which I made. We all talk about antibiotic resistance. It's or any resistance to anything. But this is in, say, 1970s to 1980s. In 2000, everything has changed. The food we eat has changed. The microbiome has changed. The lifestyle has changed. So how do you expect a drug? Let's forget about antibiotics. Everybody talks about antibiotic resistance. Resistance is not only just to antibiotics. You can even have a steroid resistance, because steroids were made for a certain level of inflammatory molecules. We have changed completely, and these molecules are driven by, inflammation is again driven by microbiome. So when you don't know what the microbiome is, then how do you treat with the same drug? So that's why when you give it the most potent steroid, or give you Avastin, Lucentis, whatever, So there's always the 20% of them who are resistant or non-responders. And as we move on, in probably by 2025, at least 40% will be resistant to your known Lucentis drugs because the body reacts to it differently. So how do you look at from a clinician from a different way is you have to probably look at all these things. I've never seen such phenomenal life surgery. I was just telling this to Srinivas that you have picked up the most toughest cases for a life surgery which is probably not seen anywhere in the country. You have picked up the small pupils, you have picked up the scleral fixated lenses. That's what you call it as more new ways of looking at things. Traditional medicine is all about you give one drug, it has to fit for everybody. But the new medicine, which I think a lot of youngsters out here, in 10 years you'll practice, is not, this is gone. This is about customizing. How do you customize this? That's when you start looking at the body from not just the cell. It's not just the flow, not just one aspect of it. God has never made it as one dimension. You have a mix of all dimensions. It's a mix of cell and mathematics. That's how I call my body as. This is how we started accidentally. I met some few scientists when I went to a conference, which was not related to ophthalmology. Sometimes we should go to conferences which is not ophthalmology. Now Abhijit he's a physicist. He was from Cleveland Clinic. He was looking after mathematical modeling, artificial intelligence. Arka was in NIH, and he was looking at gene therapy. He owns the patent for one of the adenoviral vectors. And this is how our lab looked at that point of time. It's a very old photograph. At that point of time, it was an accidental meet, but we all shared the same kind of a passion that we had to find answers to a lot of things which we don't know. And then we moved on to build all these things over the last 8 to 10 years. And now we have close to 40 scientists, and half of them, I make it mandatory for a lot of our young residents and fellows to spend time. If any of the people are keen to spend some time in what happens in the lab, the doors are always welcome. We never have a closed system. And then we created this, again it was accidental that we had a scientist, a clinician, the mathematical team, those are a bunch of engineers, and made them all sit in one single room. In universities what happens is you have a big building for mathematical science, one building for cellular science, one building for medicine science. That is where the failure happens because you don't speak to each other. What we did was everybody is housed under one roof. So you have to keep talking to them, each other. So that's where the real science started coming up. It was not planned. It was just an accidental that we did not have space. So we had to pull everybody together in one thing. And this is what happens in a clinician's, like the day in the lab. Everything which we normally discard is preserved, stored, and labeled. And one day or the other, today or next 25, 30 years, once you cryo-freeze it, it's for life. And whenever you want it, it's like a bank locker. You take it out, you start seeing, you'll find multiple things. I keep telling this to Srinivas in one of the meetings, that it's like a pen drive. You plug the pen drive in with any of the samples, you'll tell your whole body's structure. Anything you want is all there. So coming back to this lady again, what did we do for her? What we did was we collected her tears. That's what I just showed. And I had done a confocal. Very interestingly, she had no nerves at all, which is expected in a chronic inflammation. Elaborate process of, I'm not going into all of these things. Very, very interesting find she had. One in blue is, these are all molecules. This is not the time to discuss about them pre-lunch. But the red molecules are all ones which drive inflammation, makes you hypersensitive to everything. The blue is the one which is supposed to be a protectant. That means the blue and red, the values should be matching. It's like two poles. But here, the blue and red values don't match. That's why she had more of inflammation. And that's why she was having this problem. The question is, she said, I've always been treated with Restasis, cyclosporin, and it never worked for me. From a clinician, when somebody says that, you have no answer. Oh, well, you're just one of those people where restasis is not working. So what is interesting for a cell biologist, we'll think it at a different level. Where does restasis work? Restasis work on IL-2 receptors. And what is happening in her? The IL-2 is not functioning at all. So if you keep restasis to her, she's not going to get better because there's nothing to block. It's like giving insulin to a person who is a non-diabetic. And what happened was, restasis, instead of making her better, was making her worse. So what did we do for her? We went back to the literature and found that only way these molecules can be blocked is if you use your own